One of the arguments and one of the contentions is this argument that the universe, or that their explanation, the reason why we've got so many possible beings, contingent beings, is we've got an infinite number of universe. So in universe 1, water boils at 100 degrees Celsius. In universe 2, it boils at 101 degrees. And in universe 3, it boils at 102 degrees.
Hello there, and welcome to Physically Debunked. A while ago, I watched a video by Thought Adventure Podcast, a YouTube channel that explores ideas in theology, religion, and Islam. This video was about the idea of a multiverse in physics, and was part of a series of videos which they call their evidence course. These lecture-style videos discuss evidence in favour of God's existence, and argue against theories such as the multiverse, which seem to diminish the plausibility of monotheism. Now, when a video advertises itself as being an educational lecture, I expect it to meet certain standards. If a video is supposed to be educational, then it should be fair, unbiased, and present arguments and counter-arguments accurately. This is definitely not what I saw on this video. There's something very specific that religious apologists often do that really gets on my nerves, and it's one of the things that motivated me to start this channel in the first place. What really annoys me is when, in arguments about God's existence, theists appeal to scientific ideas incorrectly. To be fair, this isn't just something that theists do. Plenty of atheists also misuse science in their arguments. But it's something that I've seen happen so many times. Theists trying to use science to argue their case, but completely botching the facts and misrepresenting the ideas. This is what I see happening in this video. There are several different kinds of multiverse that are natural extensions of modern physical theories. The plausibility then of different multiverse models is something that a physicist should evaluate. In this video, the guy never actually talks about any specific multiverse model at all. Instead, all he gives are a series of broadly philosophical arguments against the existence of a multiverse, but which are almost entirely irrelevant to the topic. And yet, he presents these as if they were knockdown arguments against the multiverse idea. This demonstrates how little he really knows about the physics of the multiverse, or his inherent bias against the idea. In this video, I want to show you this attempted refutation of the multiverse hypothesis, dissect his arguments, and hopefully demonstrate to you that the idea of a multiverse is coherent, serious, and perhaps even plausible.
Even some scientists propose the idea of a multiverse. Some scientists argue that the laws of quantum mechanics, or the implications of superstring theory, indicates that there are more than one universe out there. However, there's two problems in regards to this question about could there be a multiple number of universe, and could this provide an explanation of why limited dependent things exist, why they have the particular attributes.
The first problem I have with this video is that no specific multiverse model is actually considered in any detail. You probably noticed that he did at least mention two specific models, quantum many worlds and superstring multiverses, but that is literally it. After that name drop, nothing else about specific multiverse models is said whatsoever. It's like in Marvel movies, when words like eigenvalue and Deutsch proposition are thrown in to make it seem like someone knows the science they're talking about, but without having to go into the relevant details. This approach works fine in movies, but it simply won't do if you're actually trying to discuss an idea seriously. Since they won't talk about these multiverse models in any more detail than that, I will. Most people know broadly what a multiverse is. The multiverse hypothesis simply says that instead of there being just the one universe which we can see around us, there are actually many other universes out there which we're disconnected from, but they exist nonetheless. The multiverse is just the collection of all these separate universes. An important thing to remember though is that there is no scientific consensus on what exactly the multiverse is. There are lots of different models of the multiverse in physics, all of which are researched by physicists because they are in some way plausible. So scientists are not agreed on what kind of multiverse exists, but there's a lot of interest in multiverse models because lots of different well-established physical theories seem to quite naturally entail the existence of more universes than just our own. Let's take the two examples mentioned in the video. The first multiverse model mentioned is the many worlds interpretation of quantum theory. Quantum theory is perhaps the most successful theory in physics. It is supported by an unbelievable quantity of evidence and predicts the behaviour of individual fundamental particles to astounding accuracy. An open problem in quantum theory, however, is how exactly to interpret it. Many worlds theory is one of the mainstream interpretations and claims that quantum theory is actually a theory about many parallel worlds where we can perceive only one of them. Each branch of a quantum wave function corresponds to a different physical universe. Now, not all physicists support this interpretation, but it's undeniable that this is a very natural interpretation of quantum theory, with significant support within the scientific community. Many worlds theorists often claim that their interpretation is the only one which takes quantum mechanics seriously. The other model that was mentioned was a superstring theory multiverse. Now, there are actually different multiverses you can have within superstring theory. You can have what's known as a brane multiverse, where our universe exists on an object called a brane, and that lots of different branes exist in a higher dimensional space called the bulk. When branes within this bulk collide with one another, you get events like the Big Bang occurring. The other kind of multiverse you can get here is a landscape multiverse, where lots of different universes form from quantum fluctuations. These fluctuations reduce the energy of a certain region, causing them to become isolated pocket universes, with different sets of laws to one another. There are also many more kinds of multiverse, some of which are much easier to understand than string theory based ones. One model I particularly like is where new universes are created inside black holes when they form. There are all sorts of multiverse proposals, so it's difficult to say anything too general about them. What we can probably say though is that each different multiverse model is a result of naturally extending pre-existing physical theories. We don't just postulate that many universes exist because we want them to. They seem to be natural consequences of many of the physics theories which we research. One piece of evidence then in favour of the existence of a multiverse of some kind is that there are so many theories in which multiple universes are naturally produced.
Well, the first problem is this. It still doesn't provide an explanation why limited contingent beings exist in the first place. Why does each universe have a specific set of attributes and a specific set of patterns different to another universe? So why is universe A like this and universe B like that? It doesn't provide an explanation. It's just simply saying this universe exists and this universe exists and this one has a possible existence and that one has a possible existence. We've still not explained why they exist in the first place. Therefore, it's not an explanation to the existence of limited contingent beings.
The first objection to multiverse proposals mentioned is that they don't explain why each universe and the things within them exist. Rather than being a legitimate problem with the idea, this objection seems to me to expose a misunderstanding of what the multiverse is. In general multiverse scenarios, you have some mechanism which is responsible for generating the different universes in your multiverse. In string theory, it's brane dynamics. In other theories, we have bubble nucleation, black holes, and all other kinds of things. In a general multiverse model, we do have an explanation of why each universe is the way it is. You need to trace back that universe's history to how it was originally generated. Asking why universes in the multiverse picture are the way they are is analogous to asking why planets in our universe are the way they are. Different planets have wildly different properties and characteristics, but one can always explain the features of any given planet if one knows its history and the general laws of planet formation. He seems to assume that universes in the multiverse are just random, contingent, completely disconnected entities with no explanation for their features. This is wrong in the same way that it would be wrong to say that there's no explanation for the variety of different planets in our universe. In the multiverse picture, universes, like planets, are products of history. There is a particular universe-generating mechanism which, along with history, would explain the features of any given universe.
Even if we grant the idea that there is an infinite number of universes or multiverses, we still have a problem, and that problem is the problem is this idea that you can have an infinite number of finite things. So if you've got an infinite number of universes, what you're saying is you've got 1, 2, 3, 4, 5 to infinity number of universes. So you have an infinite number of limited things. So one universe is limited, self-contained, different to another universe. And some people say, well, that's a possibility because, you know, doesn't numbers go on forever? Don't numbers just keep going on? You can keep adding 1 to a particular set of numbers and go on forever. So couldn't the universe be like that? And we say that the statement, an infinite sum of finite things, we say this is an impossibility. And it's a contradiction, it's an irrational argument, it's a rational idea. And there's a number of ways of arguing this and demonstrating how it's irrational. The first way is to look at the issue, to give an analogy about marbles. Actually, before I give the analogy of marbles, I want to just explain this point about numbers. And do numbers in actuality go on forever, even though there's no terminating number? Or maybe another way to look at it, can I count when I start from 1 and I continue counting 2, 3, 4, 5? Can I continue counting and reach the infinite number? Now most people would say, well, that's impossible, you can't do that. Because every number you land upon will be what? A finite number. So if you even go a trillion, you'd have a trillion and 1. It's a finite number. A squillion and 1, still a finite number. So you can never actually reach infinite number. What you reach is another finite number. So when we say the numbers go on forever, even if we count and we take out the concept of, you know, we say we've got an eternal life, we're still counting. We will always land upon a finite set of numbers. Yeah, it's a finite number. And even if somebody says, yeah, you can reach infinite, well, okay, what was the number just before you got to infinity? Obviously, there is no number just before infinity. The other example that I wanted to give was the example of an infinite pile of marbles. Just to explain and just also demonstrate the irrationality of this statement of an infinite finite things. Infinite sum of finite things. So imagine you had an infinite number of marbles. And this big pile of marbles with an infinite number of marbles, you cut them in half exactly. How many number of marbles do you have in each of the halves? Now somebody might say, well, they become finite. Well, if they became a finite number, a limited number, then limited pile of marbles add a limited pile of marbles would equal a limited number of marbles. So when you cut the marbles in half, you have to have infinite number of marbles in one half and another infinite in the other pile of marbles. And in fact, if you create 4 piles, yeah, I cut them into quarters, 4 piles of marbles, then every pile of marbles would have to be infinite, because when you add infinite plus infinite plus infinite plus infinite equals infinite. If they became limited, then limited plus limited plus limited plus limited would equal a limited number. So every fraction of an infinite sum of finite things would have to be infinite. Every fraction would have to have contained an infinite amount of things. Now, there's a contradiction that we're starting to see. One of these contradictions is why, when we say that the infinite is being subdivided here, if I was to take 3 marbles away from the infinite pile of marbles, the original pile that I had, have I decreased infinity? The answer would be no. You haven't decreased the number of marbles, because the marbles are still infinite. But if you not decrease the number of marbles, then where those 3 marbles come from? Not only this, but those 3 marbles are a fraction of the overall number of marbles. And we said every fraction of an infinite sum of finite things has to be infinite. But here we have a proportion, a fraction, which is finite, i3, 3 marbles of the overall pile. So the proportion of the pile of marbles is equivalent to the proportion of the 3. So if the 3 is a finite number, then the overall would also be finite, would also be limited. If we are saying that it's infinite, then we have this contradiction, this paradox, where we're saying every fraction is infinite, but then we create a fraction of taking 3 marbles away from the overall, and it's not infinite anymore.
I think I've made it clear in other videos that I don't find arguments against the existence of actual infinities plausible at all. If infinity is a coherent and consistent concept in mathematics, I see no reason why it can't coherently and consistently exist in nature. The paradoxes that he mentions here do deserve some attention, but can quite quickly be dispelled with a proper knowledge of how transfinite mathematics works. Many of these arguments rely on assuming that infinities are formed sequentially, or that normal operations on real numbers, like division, apply just the same to transfinite numbers. Well, there is no need to expect that infinities in multiverse models are formed sequentially, and the assumption that you can divide transfinite numbers is false. But I don't really need to go into this, because this objection to the multiverse idea fails to land at all. This brings me back to my original point that this person clearly has no idea what the content of multiverse theories actually is. There's absolutely no need for there to be an actual infinite number of universes in any of these multiverse theories. They work perfectly fine as explanations with a very large but finite number of other universes. Take the cosmological constant problem, for example. One problem that multiverses aim to solve is the fact that our universe seems to have a mysteriously small value for the cosmological constant. The multiverse solves this problem since, in the multiverse, there are a large number of other universes, each with a different value for this constant. We find ourselves in a universe with a small constant because life can only exist in universes such as these. This solution to the constant problem works just fine with a finite number of universes, so long as this number is large enough for there to be a sizable number of universes with a small cosmological constant. We don't need there to be an infinite number of universes. We don't need the cosmological constant to take every real number value. It can take discrete values, so long as some of these are small ones. He goes on and on about the impossibility of an infinite, but this isn't really that relevant to the multiverse proposal. There's no need for there to be an actual infinite number of universes.
So when we look at this argument about infinite sum of finite things, we say it's an impossibility. And this is not just something which I said or a few people said. Even famous mathematicians like David Hilbert has mentioned the point that this idea of infinity is not the basis of rational thinking. You can't use it as a basis of rational thinking. He even argued that there is nothing within the universe, whether that is a circle, the most spherical thing that we know is an electron, whether it is even the universe and its expansion, there's nothing within the universe that is actually infinite.
David Hilbert was a mathematical genius, and many mathematicians do agree with him that the infinite should not have any place in physical reality. There are lots of mathematicians, though, who don't agree with this, and it's actually a very controversial topic in philosophy of mathematics. There is no consensus over whether actual mathematical infinities can exist in nature or not. perhaps mathematicians like Hilbert are right, and that everything in our physical reality is finite. But remember that mathematicians also used to think that imaginary numbers would never have a place in nature. Nowadays, our most fundamental theories of the microscopic world cannot function without the imaginary unit I. So it's really not safe to say that we definitely can't have actual infinities turning up in physics.
And we can use this argument that the sum of finite is always finite to explain that the universe is finite. So if I can measure the distance between 2 points, between this point, point A and point B, and we say it's 1 meter, then I know that the rest of the universe is a fraction, a proportion over these 2 points. And if the fraction and proportion is finite, then the universe must also be finite, even without measuring the entirety of the universe.
If the argument were that easy, you'd expect it to be scientific consensus by now. Reality check, it's not. As far as we know, observations are completely consistent with the universe being infinite in space.
So what we've shown is that the sum of finite is always finite. Therefore, there has to be, even if we're talking about other universes, there has to be a finite number of other universes. They're still limited, contingent, dependent beings.
It really amazes me how little of this video actually has anything to do with multiverse theories. He briefly mentioned quantum and superstring theory multiverses at the beginning, and then never mentions anything directly related to these ideas again. This video is just irrelevant to multiverse proposals.
So this contention that is used by some atheists fails to be a rational basis to really undermine the proof for the existence of the Creator.
On the contrary, multiverses with finite numbers of universes are completely untouched by your arguments here, and their existence is far more plausible than God's. Thank you very much for watching, and I hope you enjoyed. Please like and subscribe for more Physically Debunked.